Welcome back to another explainer on the Foundry by Forge College. If you caught our last lesson, introducing the Web3 evolution, you know we talked all about how Web3 basically flips traditional internet architecture entirely on its head. It kicks out those centralized platforms and brings in decentralized networks. But, plotting a revolution is the easy part. Actually running it day to day, well, that is exactly where things get tricky.
Which brings us to the ultimate CEO problem. Think about it for a second. Imagine you've got this massive global organization, but there's no boss, there's no boardroom, and literally no central human authority calling the shots. It's just a community and a bunch of code. Now, that sounds incredibly utopian and cool, right? Well, right up until the group actually needs to make a critical decision, or worse, someone misbehaves and there's no referee around to blow the whistle. So how do we actually agree on anything?
Okay, let's dive right into this. We're going to break this down into 5 key areas today. First, the trust problem and plumbing. Second, decision-making patterns. Third, real-world trade-offs. Fourth, a quick look under the hood at smart contracts. And finally, our conclusion and next steps.
Starting with Section 1, the trust problem and plumbing. In traditional systems, trust usually lives inside human institutions. Think banks, tech companies, government regulators. But in Web3, that trust shifts entirely over to transparent protocol rules.
See, in Web3, transparency isn't just some corporate buzzword they slap on a marketing brochure. It is absolutely the foundation of the whole shebang. Because there is no central CEO to trust, you have to be able to verify every single transaction and every line of smart contract code yourself. You're not trusting a person anymore. You're trusting the cold, hard, completely observable math of the ledger. So think of these 3 pillars as the literal plumbing, the physical pipes of this decentralized machine. You've got cryptographic signatures, which are the pipes proving exactly who did what. Then you have immutable timestamps, and those lock in the exact order of events, so absolutely nobody can go back and rewrite history to make themselves look good. And finally, data availability ensures that anyone, anywhere, can double-check the receipts. Together, these pipes convert raw chaos into verifiable facts, entirely without needing to trust a centralized reporter. All right, Section 2. Web3 decision-making patterns. Moving up a layer on our blueprint here, we transition from those foundational pipes to the operational gears. How are collective changes to this protocol actually made? And here's the thing. Every single governance mechanism comes with a really delicate trade-off. Take on-chain token voting. It's highly transparent, sure, but it is incredibly slow. And if a few wealthy people hold all the tokens, it creates huge centralization risks. Delegated governance speeds things up by letting you vote through representatives, but that introduces the risk of those delegates being corrupted or captured. What about a multi-sig controller, where just a small group holds the keys? Blazingly fast, absolutely, but highly centralized. There is simply no perfect utopian setup here, only the right gear for the specific risks a project is willing to take on. Which brings us to Section 3, real-world governance trade-offs. So what actually happens when we take all these pristine theoretical gears and test them out in the messy, chaotic reality of human behavior? Well, in theory, governance is this perfect democracy, perfect transparency, broad participation, perfectly deterministic rules. But in reality, a protocol launches, and suddenly a tiny handful of early investors, affectionately called whales because of their massive wallets, accumulate so much voting power they can just unilaterally decide the outcome of any vote. Combine that with opaque, behind-the-scenes form negotiations, and you quickly realize that technical decentralization does not automatically equal fairness. And this really highlights the absolute limit of trustless systems. Because code is entirely literal, it's kind of like a genie granting a wish exactly as you worded it, even if it totally ruins your life. It enforces rules exactly as written. If a proposal contains some exploitable edge case, the smart contract doesn't pause and ask, wait guys, is this actually what you meant? No way. It just blindly executes the flaw. And that is exactly why human coordination and dispute resolution remain totally vital in Web3. Moving on to Section 4, under the hood of smart contracts. Let's actually pop the hood and see how this all builds into the engine of the system. Now, I know the code itself can look a little intimidating at first glance, but the mechanical flow is actually just 3 highly logical steps. Step 1 is propose. Someone defines a target action and opens a voting window. Step 2 is vote. This is where the smart contract mathematically tallies the voting power for or against the proposal. And step 3 is execute. If the required threshold is met by the time that window closes, boom, the contract automatically triggers the action.
It's an exact mathematical mechanism that takes a social idea and turns it into an irreversible reality on the ledger.
And that brings us to Section 5, Conclusion and Next Steps. Let's take a step back and look at the whole finalized blueprint we've just reverse engineered together here.
If there's just one core takeaway you get from this explainer today, make it this. The plumbing, those signatures and timestamps, they create undeniable facts. The governance mechanisms allow us to make necessary trade-offs between speed and decentralization, but at the end of the day, humans are still required to manage ambiguity. Trustless code handles the execution for sure, but social coordination handles the intent. I want to leave you with a bit of a provocative mental model here. The next time you're looking at a Web3 protocol, ask yourself two critical things. First, who actually holds the real decision power here? And second, what off-chain human actors can still alter or delay the final outcome? Honestly, evaluating those two questions is really the only way to figure out if a system is genuinely decentralized or if it's just shifted the power over to a shiny new set of on-chain bosses. Because remember, governance determines who makes the rules, but incentives, they determine how people actually behave under those rules. That's exactly why next up, we'll be covering economic incentives in value in Web3 to dive super deep into tokenomics. Until then, make sure you head over to forge.college to learn more about this subject, grab some extra resources, and continue your journey into the foundations of blockchain. See you next time.